Hello. In our previous video, you saw how to determine the median value for a distribution. In this video, we're going to extend this. If you recall, the median value is the value of a variable, value of x, if you will, at the 50th percentile, in the middle. Okay, and what we're going to do here is we're going to show you how to find the median in a frequency distribution table. Frequency distribution table. Okay, so what we're going to start with is we're going to start by creating a frequency distribution table here. We'll say this is variable x, and we've got a frequency distribution. X has values of 0, 1, 2, and 3. And we'll say that the frequency distribution looks like this. So there are 5 zeros, 13 ones, 18 twos, and 9 threes. Okay, and then that gives us a total sample size of 5 and 13 is 18, plus 18 is 36, and 9 is 45. And so this is what our frequency distribution looks like. And what we want to find now is we want to find the value of x. Okay, we want to find the value of this variable x at the 50th percentile, or in the middle of the distribution. And so the first thing that we need to do is we need to find the median position. Median position. And when we had an array of numbers, we just sort of counted from one side to the other, and we said, okay, if we have 7 observations, then the 50th percentile, or the middle observation, is observation number 4. In this case, when we've got a frequency distribution and we've got an n that's larger than a simple array can handle, then we need to calculate the median position. And to do that, we'll use this formula, n plus 1 divided by 2. And so what this will tell you is, this is going to tell you which observation in a rank ordered list of observations will have the median value. And so, for example, in this example, we can say that the median position is going to be 45, the sample size 45, plus 1 divided by 2. So that's going to be 46 divided by 2, which is going to be 23. And so what we want to find is, we want to find the 23rd observation. Okay, if we think of these as being rank ordered from the lowest value, 0, to the highest value, the top number 3, we want to find the 23rd observation in this list. Now, to do this, we can do this using cumulative frequencies. And so let's go ahead and we'll create a cumulative frequency column here. Okay, here's our cumulative frequency column. And then we'll go through our process of creating the cumulative frequencies here. 5 is the first one. Add 13, we get 18. Add another 18, we get 36. And then add 9 and we get 45. Now, what we're looking for here is the 23rd observation. And so what we need to find is we're going to find the CF, or the cumulative frequency, just greater than 23. So we're going to start at the lowest value of x. Okay, so let's start at this low value of x, 0, and we'll look at the cumulative frequency, and that's a 5. Is that greater than 23? No, it is not. So now we'll move to the next one. The cumulative frequency is 18. Is this greater than 23? No, it's not. So now we look to the third category, where x is 2. We find the cumulative frequency is 36. This is greater than 23. In fact, we can look at this and say this one is less than 23. This one is less than 23. But this third category is greater than 23. And that means that the 23rd observation must lie somewhere in these 18. Okay? There were 18 observations here with a value of 1 or less. Okay, that's what the cumulative frequency tells us. But there are 36 observations with a value of 2 or less. And so what that means is that observations number 19 to 36 all have the value of 2. And somewhere in there is the 23rd observation. So in this case then, we would say that the median has a value of 2. And we know that because we know that the 23rd observation lies in the category where x equals 2. Okay, so that's kind of an involved example there. Let's go ahead and go through another one, and you'll get to see this process in action again. And so we'll go ahead and create a variable. Let's call this one variable A, and we'll get a frequency distribution going. Let's see, we've got values 1, 2, 3, 4, and 5. And let's say that we've got frequencies of 15, 25, 30, 20, and let's see, 15. Okay, and so this gives us a sample size of 15 and 25 is 40, plus 30 is 70, plus 20 is 90, plus 15, this is 105. That's our sample size. Okay, and so we want to find the median of this distribution. So we'll start off by looking for the median position. Median position. And we'll use our formula, right? N plus 1 divided by 2. So we've got 105 plus 1 divided by 2. So 106 divided by 2 is going to be 53. And so what we want to find now is we need to find the 53rd observation. The 53rd observation in this data set, in this rank ordered list of 105 observations. And so we'll go ahead and create a new column for our cumulative frequencies. And then we'll go ahead and calculate the cumulative frequencies. 15 plus 25 is 40, plus 30 is 70, plus 20 is 90, and we'll add 15 to get 105. Now, we're looking for the 53rd observation. Okay, so we'll start with the category, the lowest category, where A equals 1, and we'll say that this cumulative frequency of 15 is less than 53. We'll look at the next category, and we'll say that the cumulative frequency of 40 is also less than 53. And then when we look at the third category, we say, aha! This cumulative frequency is greater than 53. And so what this means then is that the median value, or the observation that is the median value, the 50th percentile, the middle value in this distribution, is going to be a 3. Okay, and so of these 105 observations, we've got approximately half the observations have values less than the median, and half the values have observations have values greater than the median. And so right now the 53rd observation falls into this category. We can say, again, and from a different viewpoint, we can look at this and say the cumulative frequency at 2 is 40, and the cumulative frequency for 3 is 70. And so what that means is that the 41st observation is not a 2, the 41st observation is a 3. And between observations 41 to 70, all have a value of 3. And so from that standpoint then, we know that the 53rd observation has to fall in this range. And so therefore the 53rd observation must have a value of 3, and this is the median value.